So, Kaushal, can you please tell me if the recording is started?
Yes, ma'am, it has started.
Okay, thanks a
It has
lot.
started.
Yeah, thank you. So, okay, so good afternoon, everybody, and this is our 25th lecture. In fact, we are into the last 2 weeks. The trimester has really run very fast, and in the last 2 weeks, we will be looking at very interesting and nice topics about using pointers, using structures, and so on. So, just to recap, we have looked at in the last week recursive functions, which I think most of you should have enjoyed it. I hope the assignment was enjoyable for you. I think the last question was a little challenging for the lab in the last question, but I hope many of you got it after the hints that we gave you. And we'll give you more problems on recursion so that you can practice writing recursive functions, especially slightly unnatural things that, I mean, the naturally recursive ones are easy to come by, but some things which require a little bit of thought, and especially not using globals or static variables. That is something which we should not be using unless it has been specified or required. So none of the questions in the lab required you to use globals or static variables. We did not even think of it that you will use global variables. That is why we send the announcements later. Otherwise, we would have written them in the lab itself. Okay, so are there any questions about the lab or anything about the lab that we had on Friday? Okay, I don't know whether you recall all of it. It's a little 2 days away. Okay, so what we are going to start today is our discussion on pointers. And so let's get to it. I'm sure again, most of you have seen some of the things, but it is good to look at it from the basics, step by step, and make sure that we all are on the same page. So we'll start with the syntax, the meaning of pointers. Then we'll talk about how do we use pointers along with functions. Then as we go along, we are going to talk about dynamic memory allocation using this function called malloc. And in fact, not in this order. In fact, we'll see pointers and arrays and how we deal with pointers when we are talking about arrays, even before we talk about dynamic memory allocation using malloc. Okay, so let's get to the basic syntax of pointers. Just give me a moment. Yeah. Okay. So we have seen this definition of a variable x, which we give by int x. What this statement means, we all of us know, that is, this x is the name of the variable that holds the data, which will be interpreted as an integer type, right? So this all of us understand. Now, this similar thing holds for different data types that we are aware of, that is float, double, character, and so on. We also know that this cell that is given to this integer x or integer I here, it has this memory cell or memory location which has an address, and we have been familiar with this from the beginning. In fact, possibly the first class, not first class, but the first lab, where you required the address of a variable, and scanf requires the address of the variable. So you are aware that every variable has an address. You have used the address of the variable when you used it using for the scanf function. However, we have not seen the prototype of the scanf function. So we will not see it immediately, we will see it later, but at the moment we need to know what is the prototype of the function which has an address passed to it, right? So for that we require pointers, and in fact, as you will see, there are some things that we were not able to do, like writing the swap function or some other things which required us to have pointers, and that is why we will be talking about pointers starting from today. So pointer variable is a variable whose value is going to be the address of some variable. So this in that pointer variable, you are going to store the address of some variable. And the way to define a pointer variable is this data type, which can be int, float, double, character. Then you write this star, which tells that it is a pointer variable, and then there is a variable name. So as you have usually the variable names, you can have x can itself be a pointer, a variable which is a pointer to some data type. In, let's say it's an integer data type. So immediately we have an example where we are saying int star ptr. So ptr is the name of the variable, but it is a pointer to an pointer. It is a variable which will hold an address of an integer, right? So this is what it means by this statement int star ptr. And so this pointer itself is a memory location, which itself will have its own address, but its value is going to be the address of some integer variable. At this moment, it has not been initialized. Just like if we say int x, it has not been initialized to any value. So similarly, int star ptr has not been initialized to hold the address of any integer variable. So at the moment, it is not yet initialized. Okay, so I think there is some question. Yeah, so okay, so I'll come to this void and so on, void type pointers. Yes, they are available, but we'll come to it in a minute. Not immediately. We'll come to it when it is required, right? So yeah, okay. So okay, so in this example, if the variable I, which has been defined here, let's say I have int I, and let's say I have said I is equal to 5, then let us say that if this variable I, the memory location's address is 65524, then this pointer variable can hold the address of this variable, which is I, which is this 65524, and you will be able to access this memory location, one through the variable I, the second through the pointer variable in a particular way. So we'll tell how to access this memory location in two different ways. One through the name of the variable that has been that you have used to define this memory location. The second is the pointer with which you can access it. So any questions till here? This is the very basic, and I think most of, yes.
Ma'am, here the address 65524 is actually it comes under the range of integer type, no, ma'am, like integer data type. So
Yes.
if it exceeds that, then what we do? Like,
Okay. So this number itself is given as a small number, right? But it need not be this small address, right? You have printed out the addresses of things, right? We have printed it out earlier. So the addresses of variables are much longer than this value, right? The range of this value. So a pointer data, typically the memory allocation for a pointer is 4 bytes, and it is sufficient to hold all the addresses in memory. Does it answer your question?
yes, so it doesn't depend on the data type which we use, right? Like integer or float.
No,
Like
no, it
before.
doesn't depend. It doesn't depend on the data type that you are going to. It is going to be independent of the data type.
Okay, so pointer size is 4 bytes, which is fixed.
Okay, so this leads to an interesting thing that I did not plan, but let's do it on the. So Kaushal, please tell me that you are able to see in a minute the repl.it. I'll share it in a minute. Okay. Yeah, Kaushal, can you confirm that you can see the...
Yes, ma'am.
Yeah, okay. So yeah, I would have written this program if I had planned it, but it's not a big program. So let's write it together. Yeah. So what I want to do is I want to do the following: char star ptr1 and int star ptr2 and printf %d. REPL.IT is extremely slow, so it's taking a very long time. Okay, Kaushal, can you hear me?
Yes, ma'am.
Okay. Yeah, I thought the network itself is gone. Okay. So there are some semicolons which it did not save.
Ma'am, am I audible? Hello?
Yes, you are audible. Yeah, please go ahead.
Yeah, the quotes was the problem. Like,
Yes, I see that it is automatically doing some of the things which I am not used to in my other this thing. I wish I had, yeah. So %d. I think there is still some problem. Does somebody spot the problem? Char printf %d.
size of won't be %d, right? LU.
Yeah, I think that is fine, but that is only a warning. I think that should be okay. Yeah, so that may be okay. Let me see if that is the problem. Okay. Yeah, so I think finally we have come to the standard warning that we are used to. Yeah, so anyway, so here the pointers are given 8 bytes. So on this machine or the REPL.IT environment doesn't matter, but it is going to be independent of the pointer of the data type that it is pointing to. That is what I wanted to bring out, and I hope it is clear by this example. So yeah, so that is what I wanted to say using this small example. Okay, so let's... Okay, so it is return LU. Okay, so you can look up what is LU, but it is long unsigned. So it is not returning it is not returning an integer. It is returning because the addresses won't be negative. So therefore it is not the data type. Yeah, it is that the incorrect data type if I use %d. Okay, so this is 8 bytes. If you are on this environment, it is 8 byte. 8 bytes. It can be different on different things, but on this REPL.IT or this environment, it is giving 8 bytes, or with this compiler, it is giving 8 bytes. Yeah. Okay, but the point is not about 8 bytes. It is about the fact that irrespective of what data type you have defined the pointer for, it is having the same number of bytes that are there. Okay, so yeah. Okay, any other question? Okay, so let's get to so let's say that I have defined this int star ptr1 char star ptr2, And again, it is useful for us to name our variables appropriately rather than calling them X, Y or something. It is good to call them with names which indicate that they are pointers, so that when we use them, we also use them appropriately. It's not mandatory, but it is good to have naming conventions like that. Okay, so which integer or character are they pointing to? As I said earlier, that unless we initialize them, they are having garbage values, just like our integers or characters which were not initialized will have garbage values. So it is undetermined, right? So if you want to assign this pointer to be pointing to a particular integer or a particular character, you need to provide that you need to make that link. That is why it is called a pointer, that it is going to point to something. So if you want this ptr1 to point to a variable called x, then you can say ptr1 equal to and x, and this assigns the address of the memory cell which is assigned for x, and then ptr is always going to point to that unless you change this ptr by an explicit thing. So unless you change this ptr, the value contained in ptr will be the address of this variable x. Similarly, now that you have assigned some memory, you have assigned this pointer the address of something, you may also want to access that memory location using that pointer. And when we have a variable defined as x, to access the memory location x, we just use the variable name x. However, when the pointer is pointing to it, we are going to access that using this dereferencing operator, which is this star operator. So this star ptr1 gives us the value of the variable that is stored in that memory location, which the ptr1 is pointing to. So this is only true if you have initialized the pointer. If you say int star ptr1 and in some place you say printf %d star ptr1, then it is meaningless because ptr1 has never been initialized to point to something. So you can expect it to point to garbage value. You can expect it to give a core dump because that memory that it is referring to may not be in the scope of your program. Therefore, you can also get a core dump. So is this clear? Are there any questions here?
Excuse me.
Okay. Yeah. So yes, you have a question?
Yes, ma'am. In the example, PTR1 is equal to ampersand x. Can we change the value of PTR1 like PTR1 plus plus?
Okay, so PTR1 is already containing something. And if you do PTR1 is equal to PTR1 plus plus, yes, it is valid. But unless you have initialized it, it is meaningless, right? Similar, if you have said int x, without initializing it, you say x plus plus. What meaning does it have?
No, after initialization, I'm asking.
Yes, so after initialization, it is meaningful. But what do you want to do using PTR1 plus plus?
No, I'm just asking, ma'am. Is it valid?
Yes, you can do PTR1 plus plus, and we will actually see that it will be very useful when we use arrays and pointers. So it is meaningful, but it is more meaningful when we are dealing with arrays. Otherwise, there is no real reason that if you have two variables x and y, then x and y will be contiguously located and so on. So the PTR1 plus plus is not really meaningful unless you are talking about arrays and pointers. So we'll come to that when we come to arrays.
Okay,
Yes, you can do PTR1 plus plus. In fact, you can do PTR plus 2 and so on also.
yes, ma'am.
Yes.
Thank you.
Okay, sure. So there are some other questions. Yeah, so let's come to, let's just get over the basics and then talk about PTR1 plus plus, right? Yeah. Okay, so yeah, so now let's come to talking about this initialization and dereferencing once again to make sure that we are all on the same page. This int var is equal to 10 is the normal statement that you are familiar with. This will define a variable integer variable called var, and it will assign this memory cell or initialize this memory cell using 10. Then we also have a pointer variable p, which is a pointer to an integer data type, and this is the cell for p. Whatever is written below is in fact the address of the variable p itself. Once you say p is equal to and var, then it is going to put into this cell the memory for p. It is going to put the address of the variable var, which is the address here. This is only in the example, so you may not be able to simulate this, but whatever is the variable's address, you are going to have the same as this memory cell's value, because you are doing this statement p is equal to and var. And this is what is assigning the value of this, or making the pointer point to this variable. This is the language that we will use. Okay, so what I want to say is that whenever you have a variable, we know that it already has a value, it has a type, which is the integer type, it has an address. Now, whenever you have a pointer, the pointer itself has its address, which we see here in this example. This is the address of this pointer, and the value of the pointer is going to be the address of some variable. It depends on what is the pointer pointing to. The pointer is a pointer pointing to an integer, then it is going to be the address of an integer variable, or it is an address of a character variable, or it can be the address of something else also as we go along. Okay, so let's read this piece of code, which has the following things. That is, it has int x, y. These are two integers. There is another variable which is a pointer, which is ptr1, which is a pointer to an integer. While we have done these three statements, there is no initialization for x, there is no initialization for y, there is no initialization for the pointer. Then we are saying ptr1 is equal to and x. At this point, x is not initialized. The value of x is not known, but ptr1 is pointing to x that we have set up by setting the value of ptr1 to contain the address of x. After this, we are initializing x is equal to 10, and then we are saying y is equal to star ptr1, right? So and finally we are doing x plus plus. So let's say we print out the values of x, y, and star ptr1. So let's say we write three printf statements, or a single printf statement, printf %d %d %d. What are the values of these x, y, and star ptr1? Okay, so I hope that x plus plus is clear. So the x value has certainly increased. So x should be printed out as 11. So there's no confusion about that. Then y is something that is equal to star ptr. So y itself is a variable which will have its cell where you can store integer values, and we have already taken the value pointed to by ptr and dereferenced that value and stored it into y before x was incremented. ptr1 was of course pointing to x, so the value of x is going to be given to y, therefore y has been set to 10. But ptr1 is pointing to x, therefore ptr1 itself is the same as star ptr1 is the same as accessing x, therefore you are going to get an 11 for the third value. So the values that are going to be printed out are 11, 10, and 11 respectively if you execute this piece of code. Are there any questions here? Okay, let me just see this. Okay, so int star ptr is equal to and ptr. Yes, you can give that, Aishwarya. But what is the purpose?
I'm just asking, like, can we store the values, the address of pointer
Yeah, but it will give you a warning. These two are not compatible. So it will give you a warning.
Okay.
Yeah. We'll come to pointers. Just let's go a little slow. I know that some of you may find this repetitive, but it is good to go over these from the basics rather than jump over things so that everybody is in the same this thing. Yeah. Okay. So let's just go over the okay, let me just read the, can we not write PTR1 is equal to 3 or any other number which might not be an address? So Rishabh, can you please say your question or unmute yourself and ask the question?
Yes, ma'am. Like here we have initialized PTR1 as ampersand x, right? So we cannot initialize it as PTR1 equals to any number, arbitrary number. We cannot initialize like that, right? A pointer.
See, you can initialize it, but that will not be a valid memory address into the scope of your program, right? It need not be. I mean, so you may be accessing something which is not a valid memory access, which is not a valid thing for your program to access.
Okay, ma'am. Yes, ma'am.
Right? Yeah. Okay. So let us just understand this. So let's say we add the following lines of code to this program. So it is very helpful for you to draw figures and have these memory cells and have these pointers actually pointing to the appropriate variables when you are dealing with pointers. So I strongly encourage all of you to use a notebook and draw these cells. If I were doing this on the board, I would have certainly gone to the board and drawn this. I will also try to annotate it and see if I can do it, but you know my limitations. So, okay, but I think all of you should try to do this and tell me what are the values of X, Y, and star PTR after this. So assume that this piece of code was already there. So already at this point, X was 11, Y was initialized to X, and then PTR1 was pointing to X. So this was the story at this place here where my cursor is. After this, suppose you add these lines, that is PTR1 is equal to and Y, and star PTR, I have carefully given the brackets and then done plus plus. Okay, so the answers seem to be 11, 11, 11. Why is it not 12? Why is nobody writing 12? We are doing plus plus twice. Okay, so I hope everybody sees this, that initially there was this cell for so I'm okay, so there is this cell for X, there is this cell for Y, and there is this cell for PTR. So this is X, Y, and PTR. So I'll just write P. And initially X was 10. So that was incremented by this statement. So this went to 11. Yeah, I'm so sorry. Okay, so this cell went to, this cell X was done plus plus. So this got incremented to 11. Then this Y was initialized to 10 by this statement, which is Y is equal to star PTR1. That was done before this X plus plus happened. So therefore that was not changed. Now you are saying PTR1 is equal to Y. So what you have done by this statement is PTR1 was pointing to X. Now this you have changed and you have deleted this pointer and made this PTR1 is equal to Y, and therefore Y PTR1 is pointing here. Now you are saying star PTR1, that is first dereference whatever is there in PTR1 and do a plus plus. Therefore now you are going to increment this position, which is this memory cell, to be incremented by 1, which this 10 gets incremented by 1. Therefore, you are going to get 11 here. This was already 11. This is 11 and y continues, sorry, PTR1 continues to point to y. Therefore, all three values are going to print out 11, 11, 11. So all those who answered 11, 11, 11 is correct. The reason for this is as given below. Any questions here? Okay, so I am not going to do this ever in this thing in, we should not be using it like that, but I am just telling you that you can look up what happens if you omit these brackets, that is these brackets are not there if you do star PTR1 plus plus. We are not going to do this, as I have said earlier, we are not going to rely on you memorizing the table, the operator precedence table, but I would like you to do this offline, find out what happens and why is it what happens. You should be able to reason it out. So the question is, what if you omit these braces that I have given here, the brackets that I have given, and simply write star PTR1 plus plus? Is it syntactically valid? What does it mean if it is syntactically valid? And what answer does it give out to you? So please try it out yourself and then try to reason out. Okay, any questions here? Okay, so let's look at the, yeah, so Ashwin, I am not going to answer it. I have left it to you. Please think about what happens and what is the answer that you get after printing out X, Y, and Z. Does it give out a syntactically correct thing and so on? Okay, so let's read the following program and try to answer what are the values that get printed out here. So there's nothing specific or nothing tricky about this program, but just read the program and tell us what happens when you when this program executes. So count is equal to 10 is clear. I mean, there's nothing specific. Count has been initialized to 10. So this printf is going to print out count. That is clear. This same variable count, we have seen it earlier. You can also access it using count PTR. Count PTR is a pointer to an integer which has been initialized to the address of count. So this is going to print out the same value that count prints out unless there was a change here. So therefore it is going to print out the same value. It is just accessing it in a different way, which is star count PTR. Finally, the last two statements are address of the variable count, which is printed using AND count, and the value of the count PTR, which has been printed in hexadecimal so that it matches exactly the address of count, which will get printed via %p. Right? So if you print out this value of this count PTR in hexadecimal, which is using this %x, then the last two statements are going to print out the address of count. The first two statements are going to print out the value of count. It is just showing that the same value can be accessed using two different ways. One via this variable count, the second via this star count PTR, which has been correctly initialized to hold the address of the variable count. So nothing difficult, just illustrating the dereferencing, etc. using this newly defined things. Okay, I assume that this is clear. Yeah.
Suppose we want to print out the address of, the value that count PTR holds, right, which is the address of count without using hexadecimal, then
% without using?
Not in hexadecimal notation.
Okay, so you print out %p.
%p there. Okay.
Yeah. Okay, so, oh, sorry. You want to just print out that, right? So, yeah, so I don't know, maybe you will have to use some long, this thing, yeah.
LU, ma'am.
LU or something. Yeah, you can try out that.
Okay.
Yeah, we can try it out in the break, Chinmay, right?
Yes, ma'am.
Yeah, we can try it out in the break. Yeah. Okay, any other question? Okay, so yeah, so let's read the following program and just try to understand it. Again, it is very basics of pointers. I am going slow a little bit, but making sure that everybody is on the same page. And if you have any questions, we can go over it quickly. Okay, so please note that every time we are using pointers, we are trying to have some kind of PTR, P or something in the variable naming. It is again recommended, not mandatory, but it helps us. Okay, any question or comment? I can hear some noise. Hello, can you hear me?
We can hear you.
Okay, great. Okay, so let's read through this program again. It's a simple program. So we have an integer C. C has been initialized to 22. We print the address of C using and C, which we know that it will be printed out as with %P. Then the value of C here is of course going to be printed out as whatever is the value of C, which is 22. Here, when we do PC is equal to and C, this is setting the pointer to point to C. Yes. Yes. We are using pointers, we are trying to have. Is there a question? Hello? Yes.
Ma'am, can you hear me, ma'am?
Who is speaking? Can you please tell us? I can't see the name of the person speaking. Okay, so I assume that there is some connection issue. Okay, so at this stage, when we have reached this line of code, we have the pointer pointing to the integer variable C, because we have said PC is equal to and C. Now the address stored in the pointer is going to give out the address of the variable C, and by just saying that the content of the location, we are just saying that we are print. So what is it that is going to get printed out by this statement, printf the content of the location pointed to by PC? Anybody? Yeah, so it is simply going to be 22 because PC is pointing to that. So there's nothing new about this. At this stage, we are going to change the value of C equal to 11. And then this statement, that is address in the pointer PC, does it change by this statement? So what I want to ask is the statement, the value that is printed here versus the value that is printed here, is there going to be a change? No, because the address remains the same. It does not change. However, the content has changed because C has changed. Therefore, PC was pointing to C. Therefore, at this stage, you are going to print out 11 again. So the value of C has changed, which is also whatever is PC pointing to. Therefore, that star PC is going to print out 11 at this stage versus it was printing out 22 here. Now we do star PC is equal to 2. Now address of C again is not going to change. Therefore, these three values are going to print out the same thing. That is these three statements, address stored in pointer C, pointer PC, they are always going to print out the same address. However, the value keeps changing. It will print out 22 first, C 11 next, and 2 next. So the point of this example is to tell you that the value in that cell C can be modified via two things. One is via assigning C something, what we have done here, versus by assigning star PC to something else, which changes the same cell as long as PC is pointing to the variable C or the address of this, or contains the address of this C. Okay, any questions here? Okay, so I think this is a good time to take a break. We'll take a break for 2 or 3 minutes and come back. I'm going to pause the recording. Good. So coming back, now let's look at an application of these pointers and in a simple function that we have already seen. So this is a function that you have already seen, which is this swap function. So although I write here predict the output of the following program, you know what is the output. We have called this function earlier when we have seen this, and we have seen that this is an incorrect way to write the swap function. The reason is that these variables are passed by value. So while inside this swap here, x and y are indeed swapped out, but when you come back here, they were the copies of x and y, and the swap doesn't reflect to the caller, which is the main, and therefore a and b continue to print out 10 and 12, 10 and 20. So this is, we know, is an incorrect program. So no swapping happens. And now that I see that you people are so hooked to globals, I would assume that what you will want to do is that you want to set them as globals. But then globals is really not something which is useful, because if I were to write a function, I don't want to write function to swap two globals. Typically, I would want to write a function which will swap two variables which I am passing to it. So globals are, I mean, they are convenient for just making this program work, but then there is no point of writing a swap function. And in general, using globals is quite dangerous. So avoid them, do not use them freely. The globals are convenient at various places. In the swap function, it is a very incorrect or a very bad way of using it. There's no point in writing the swap function like that. But still it may work out. So, but in general, use globals with caution. So now let's look at the correct way of writing the swap function using this newly learned concept of pointers. So what we know is that we cannot just send these values, we cannot pass these variables as it is, because it is passed by value and you will simply pass a copy of them. So we in fact want to send addresses of these variables. And as somebody had already told me when I wrote this swap function earlier, that you must write swap and x and a and b, which was fine, but we did not even know how to write the prototype of the function, which will take two pointers. Now that we have defined pointers, we know that these are addresses of integers. Therefore, we must have the swap function to take in two addresses of integers, which can be given as int star p1, int star p2. And now of course swap does not return anything, so therefore the return type of swap return remains to be void. Now we have an integer int t, which is the temporary integer that we have taken. In t, we are going to take the whatever resides in this pointer p1. Remember that p1 is a pointer to an integer, so you cannot say t is equal to p1. This is syntactically incorrect. So t is equal to star p1. So let me again try an attempt to write the notations. So okay, so there are a and b which are in main. When we are sending this p1, p1 is a pointer to a, p2 is a pointer to b, and when you are saying t is equal to star p1, whatever is in p1 is going to get copied to t. So this contains 10 and this contains 20, so t will contain 10. And then star p1 is equal to star p2. So if you are accessing this cell and you are going to change this to be equal to 20. Yeah. And then star p2 is equal to t, which was initialized to 10. So therefore that will get to 10. And therefore these cells which were a and b get actually swapped to 10, swapped respectively to contain 20 and 10 after this function executes. So this is a correct way to write swap. And now that you have written this swap, you can call this swap from anywhere, from different places in either main or different functions at each time, as long as you send the addresses of the variables that you need to swap. This swap function is going to correctly swap the two variables. So while swap is not the most important function that you may want to write, because it's such a 3-line function that you can quickly write it then and there, but this illustrates the difficulty that is posed by pass by value, and you cannot simply do a swap, which we did earlier, which was the original version of swap. I think I have it here, so it will come up. Yeah, so the original version which does not work, whereas this new version which will work and which will correctly swap out the values. So any question here? Okay, so Rishabh, I'm going to come to your question in a minute. Yeah.
Just a small doubt, ma'am.
Yes.
In the function header, like, and if I mean the function thing, we wrote void
Prototype.
swap is equal. Yeah, yes, ma'am. We wrote int asterisk p1 comma int asterisk p2. Can we write int p1 comma int p2, because it's just taking the address, not the value, right? Like p1 is going to store the address of a and b, but so asterisk p1 will help us to access the value which is stored in that address.
No. So sorry, I didn't understand. So you want to write here int p1, int p2.
Yeah, yes, ma'am. Yes, ma'am.
If you write int p1, int p2, you cannot call it with and of a and of b.
But while initializing, we just give the variable, like we give int asterisk some p1, for example, then we say p1 is equal to ampersand of the values address which we want. So why can't we do that?
No. Wait, this is okay. So okay, so what does this int star p1 tell? What is the meaning of this?
That is, we are defining a pointer. Like,
correct. So okay, so if you say that this swap takes int p1, then so this statement is not equivalent to saying p1 is equal to and a, right? That is not the statement that you are saying. You are telling what is the type of the variable, the first variable that swap takes. It is an integer pointer. That is what you want to tell by this statement, right? So you have to convey to the compiler that you must expect an integer pointer. So you must write int star p1. You cannot write int p1.
okay.
Yes.
I get it.
Okay. I mean, it won't be syntactically correct itself. Okay. So I think Lakshya Prasad, right? You have some question. Can you please tell me P1 is star P1 is equal to and A? Okay, I don't understand your question. So Lakshya Prasad, right? You have asked. So Rishabh, I see your question, but I'm going to come to it in a minute. So I'm not answering that. Okay, so I hope, okay, so I think your doubt is cleared with Kannikeshwar's doubt, so it's fine. Okay, so yeah, so I just want to emphasize what has happened when we did this, when we implemented the correct swap function is that while we know that all arguments are passed by value, what we have done is simulated pass by reference. That is, we have created the effect that we have passed by reference when we have passed the addresses of these two variables, and we have allowed the swap function to take in two pointers instead of two integers itself, right? So this is useful when we want some functions to be modified, some functions to modify some of the arguments, or even return some values. So in case you have two things that you want to return from a function, you can return one of them using the return value, but maybe you want to return two things. The second thing can be a parameter that is passed to the function, and that should be a pointer, and then you can put in the value inside that and return. So in fact, we will either do it today, or we'll do it in the next class, where we'll write a GCD function which will not return anything, but return via using the one of the parameters to the function, so such that a pointer is passed to it, and in that we will return the value. So rather than returning an integer the way we typically do, we will actually use one of the arguments of the functions to return some value. Okay, so the way we have achieved this is that the caller is calling it using by doing an AND, that is, it is sending the address. In fact, we have done this earlier. We have the first few classes itself, we have seen that scanf requires an AND, whereas the printf does not require an AND. And the function prototype must be accepting a pointer to the appropriate data type. And we'll see what does scanf have as its prototype eventually, maybe towards the end in this week when we are ready with pointers. We'll look at the prototype of the function scanf and try to understand it. And at that point, you will possibly see that something very interesting about the scanf function that will be apparent when we try to look at the scanf function in detail, the prototype as well as how it is written. I mean, not the details, but at least the prototype of the scanf function. Okay. So let us now look at the following different way of writing this swap function. So note that the
Ma'am?
yes.
Ma'am, can
yes.
you go to the previous slide 1 minute?
Sure. Yeah. Yes.
Okay, okay. I was noting down something.
Okay, sure. But you can, of course, I mean, I'll post the slides soon. Yeah, sure. Okay, so let's look at this second swap function, which is there's a small difference in the swap function that I have written, and note that it also takes 2 pointers. Therefore, we have sent A and B, and the addresses of A and B, and not A and B themselves, but addresses of A and B, and the syntactically they match because we have int star P1, int star P2. Now we are defining an integer pointer called temp, and temp is equal to P1, P1 is equal to P2, P2 is equal to temp, right? So each of you study this program, draw out those diagrams in your paper the way I have been trying to draw on the slide. Draw out this thing, and then finally tell me what is printf, what is the value of printf here. It cannot be utterly different from what it is 10 and 20. So do not give values which are outside this, but please give me the values, and also think about it. Spend time writing down the draw the pictures of the cells and how these pointers are getting manipulated. So Rishabh, right? You can draw these pictures and tell me what is the what are the values printed A and B, and we will try to analyze them. I'm just asking you to study this program and tell me what is the output. Okay, till you are studying, I'll try to draw them myself.
It will be
Yes.
unchanged number.
Sorry?
Like, as when it comes to output, nothing will happen, right? Because
Okay, please keep your answer to your chat so that everybody can think about it. Okay, so okay, good. So I see answers in this thing. Okay, so of course, there are only 2 possible answers. One answer is 10 and 20 are printed. The second answer is 20 and 10 are printed. So there are not too many possibilities, but let's make sure that we understand what is happening. So this is an incorrect swap, and most of you have pointed it out correctly, but just for the sake of everybody's understanding, this is the picture. That is, these are A and B. They have been drawn nearer to main. So these are A and B, and they have been initialized to 10 and 20 respectively. These are P1 and P2, and temp is a pointer to an integer, and that is initialized to P1. So it is incorrect to draw this arrow. This is not what is the story by temp is equal to P1. So I'm sorry, it has gone away, but okay. So yeah, so by saying temp is equal to P1, we are not saying that temp is pointing to P1. In fact, temp is also pointing to whatever is P1 pointing. So temp is also pointing to A. P1 is equal to P2. It means that P1 will start pointing to whatever is P2 pointing to. So P2 was pointing to this. So this will start pointing to P1 will start pointing to P2, which was pointing to B. And finally, P2 will start pointing to whatever is temp is pointing to, which is pointing to A. So the addresses are getting swapped, which some of you have correctly pointed out. So this is 10 and 20. The values remain as it is. And these local variables all get destroyed, just like I have shown you. Of course, A and B don't get destroyed. They remain, but A and B's values remain to be 10 and 20. And these do not get swapped at all. The addresses are swapped, but remember that these pointers themselves are passed. I mean, these things are also copied, therefore the pointer cells are also erased out. And finally, nothing has changed because we have never accessed A and B using this. So we never did star of P1, never did star of P2, right? So therefore, this is an incorrect swap. It doesn't work. But the reason I'm showing you this is because the way we initially tried to write swap was swap with int x, int y. So we said the same type of that variable temp was taken, and we said temp is equal to x, x is equal to y, y is equal to temp. So in a similar spirit, one may try to write this, but this doesn't work. And the reason is why we have shown it just a few seconds ago. Okay. Does temp point to A or does it point to P1? So temp doesn't point to P1, temp points to A because temp contains whatever P1 contains. So let's say P1 contains a big address like we had shown some time back. Temp will contain exactly the same thing. So temp is also containing the address of the same variable that P1 is containing. P1 was containing the address A, address of A, therefore temp will also contain the address of A. Is that clear, Shashank? Okay, so yes.
Ma'am, I had a doubt. Pointers are in general data type, can we say?
So pointers are data type, meaning it is a data type, yes.
So like int star PTR means that PTR can store hexadecimal values as well. Can store hexadecimal values only. And int PTR refers like it can store only integer values.
Wait, see, no, it doesn't mean that it can store hexadecimal values only. That is not the correct thing. In fact, there is nothing like hexadecimal values, right? We are taking something, I mean, it is a different way of representing things, right? The same number 10 can be represented in hexadecimal, can be represented in can be represented decimal, can be represented in octal, and so on. So just because the numbers are very large and hexadecimal is a better and a succinct way to represent it, that is why we are representing pointers using hexadecimal rather than other things, right? You could have written them using unary or binary as well, and they would be large numbers. So first of all, it's not that it is going to store only hexadecimal values. Again, it is going to store something which will be interpreted as an address of an integer variable. That is all we can say. Just like a character contains some bit pattern which is interpreted as a character, integer also contains a bit pattern which is interpreted as an integer. So you know that you can do %d of a character and it will print out the ASCII value. If you do %c for a character, then it will print out the character itself.
So ma'am, like if anyone asks like address of a the data type of an address, so what do we say now? Does it even make sense to ask that question, or
So what is the question? Can you please?
like what is the data type of an address? Suppose like here temp is storing some address value of A. So what is the data type of it? So you just say its data type is the pointer, or like every variable temp is also again a variable only. So it should have a kind of a data type, right? So
Okay, so this pointer is only a term used to store, call the address of a variable, right? So yeah, if you want to say that, so remember that temp will itself have an address, right? So you will have a pointer to a pointer. So we will come to int star star, which will be able to contain the address of a temp itself, right? Because temp is a pointer to an integer, and the address of temp is a data type which is int star star, which is a pointer to a pointer, which is of pointer to a pointer to an integer.
fine, ma'am. Okay.
Right? Yeah. Okay, so I think I'll stop here now. When we meet tomorrow, we'll again discuss more about pointers and arrays. And please come back with your questions. Yeah. Okay, I'm stopping the recording. Okay.